Hola, bona nit, benvingudes. Aquesta és la residència Top Lab en difraccions, aquí a l'Art Santa Mònica. Volia fer aquesta xerrada en català, però tenim gent que només parla anglès, llavors faré la xerrada en anglès, però podeu, bueno, és una xerrada bastant informal, hi ha gent aquí a l'espai, però igualment podem també, podeu fer preguntes en anglès, en castellà, en català. So maybe I have to switch to English for this conversation. Thanks for being here. Thank you, Lina, for all the live coding setup of the streaming and the camera and the microphone and everything. So, dades temps real i algoritmes d'aprenentatge, which would be like data, real-time learning algorithms. And this is a subject I've been working a lot for a long time. And I don't know how many of you, I mean, we are a live coding community, so probably please raise your hand if you know what live coding is at some point, so I know. So everyone knows what live coding is. So live coding is not popular. I don't know how that happens, but it happened. So basically, to me, this talk is about live coding and artificial intelligence, but of course, it also extends to other practices like creating interactive installations or design or other artistic practices using artificial intelligence. So live coding, to me, this is the focus of this talk is what can we learn from artificial intelligence by doing live coding, or which type of artificial intelligence we need if we want to do live coding, no? With being or using or observing the live coding ethos, the live coding ideas, the live coding manifesto, so to speak. I will explain that. So this is actually about artificial intelligence and live coding. And this is the question, no? I'm proposing like which type of artificial intelligence makes sense in a live coding context. And I think this is also a question for many other approaches using, I don't know, large language models or deep neural nets, for example, for text or for image generation. So maybe according to the artistic practice, maybe instead of using this big data set with these models that are already trained with images that probably we don't know where they come from, maybe it makes, for some specific practices, maybe it makes more sense to see what we want to do, and from that point, trying to figure out what type of artificial intelligence we want to use. Because I love the artificial intelligence paradigm, the idea of having machines that can learn from data and can perform some specific tasks, some interesting tasks, or some boring tasks, for example, like image recognition or the text generation, if it's simple text. Maybe for those cases, we want machines to be able to do that task automatically. So there are many things that has to be with the industry and what is happening in the industry, but there are another things that they are more close to artistic practices, and maybe for those practices we don't need or we don't want, for example, statistical means, or we don't want the general descriptors of a clusters. Maybe we want something else. So this is more or less what I want to talk about, basically the idea of artificial intelligence in live coding, these tensions, which to me is asking which type of data do we need in a live coding context. In live coding, we write algorithms in real time, so there is this real-time feedback, like a sort of a conversation between a human and the machine. And that's not the case if we are doing, for example, if we have some installation and then we leave the installation there and then the code is running, then the model could be already trained. But in live coding, we are talking about displaying or interacting with the algorithms in real time. So many machine learning algorithms, they need, if you are probably been training, I don't know, or fine-tuning large language models or models for sound generation like Rave, for example. So we know that to train that model, we need like 5 hours, a day, a week. But if we want to interact and we want to display the interaction with the algorithms, maybe the data that we can use is probably not the case. We won't be able to do this big data. So that has to be with the idea of real time. I also want to talk a bit about the Markov chains as the, let's say, the prototype of artificial intelligence versus the neural nets and the deep neural nets that, of course, are now dominating. Most of the times when we talk about AI, we are not talking about linear regression or we are not talking about decision trees. We are talking about neural nets, deep neural nets, trained with trillions of data. This is the, now artificial intelligence, in a sense, it means that. And we are not talking about symbolic artificial intelligence or symbolic algorithms, for example. No, and I'm going to try to explain all of that. Then the transformers attack, of course, and what happens in the live coding context. And to me, the final question is like, if I'm a human, can I play? No, can I do live coding like being a human? So what happens about artificial intelligence and live coding? And in 2021, Shelley, Notts, and me, we were both doing live coding and using artificial intelligence. I started using artificial intelligence because I'm a Super Collider user, and if you know Super Collider is really, the abstraction level is really low, so you have to type a lot in comparison with languages for live coding that have a really high levels of abstraction. So the amount of code you have to type, it's, if you are using tidal cycles, for example, is probably 1 line, while in Super Collider, there is the need of defining the scene depth, then defining the pattern, then defining many other layers. So I actually I got into artificial intelligence because of the type of tools I was using. So we wrote this paper with Shelley. Shelley also uses Super Collider. And the idea is like coding. We stole this from the laptop manifesto because show us your screens, obscurantism is dangerous. And we changed it to say like live coding and machine learning is dangerous. Show us your algorithms. So it was the idea of being a bit provocative. So saying like, if you are doing live coding and you say you are using machine learning, but the algorithms are not displayed, maybe you are not using machine learning in live coding. You are training some models that, yes, they have some sort of machine learning, of course. You are using machine learning to train the models, but you are only doing real time. You are only generating outputs from those models in real time rather than actually having these conversations with the algorithms. So for us, it was these tensions, no? Live coding ethos pushes to transparency, for example. We want to give the public, give the audience, and even though there is no audience, because many people in a live coding show, they also do live coding. So there is one thing that is interesting in the live coding community is that it breaks this idea of between the audience and the performers. But if you are doing live coding and if you want to show your code and you are using machine learning, are you actually letting us know what is happening on the screen, how you are using the algorithms? Maybe if we don't see that, which is the idea in a live coding context, maybe there is not such a thing like live coding and machine learning. So this paper, the idea was discussing these tensions. If obscurantism is dangerous, and if we want to see the interaction between the humans and the algorithms, then something else needs to be done. And that takes us to the data we need for in a live coding context. And I think one of the persons who has worked a lot in this, it's actually Niklas that is here. Because Niklas, and this is a bit, this is 2020, this is a year before the live coding and machine learning is dangerous. And what Niklas, that we can actually ask Niklas because Niklas is here. So the idea is, and we were having the other day a conversation with Marc Padró from Estampa and Sofia Trejo, that she works on BCC. And Sofia was pointing out, like, a lot of the artistic community is using machine learning in their pieces. We are doing a lot of work with machine learning. And I was saying, like, yes, of course, because one normal thing to do for the artistic community is using art as a way to understand the technology. So we explore with artistic practices. We try to, could this compose music? Could this write a text? Could this algorithm write a novel? To explore the limits of the technology. That's something that we normally do. But Sofia was saying, like, no, but there is an overflow. So normally the approaches are, they say they are critical, or like we say we have critical approaches to technology. Like almost every artist said, like, I'm doing this work from a critical point of view. And probably that's right. We meant that. We want to be critical, but maybe sometimes it's asking ourselves how this technology is done, how it works, and trying to see if the components we want, how technology is working, is actually useful for our practice or not. And that's what Niklas was pointing out in this paper. Niklas was like, in live coding, we want real-time feedback. We want to change something, and we want to see the changes expressed in the sound. And this idea of real-time is that. It's like, I can interact with the algorithm. And what Niklas, what is highlighted here, you cannot see it in the screen. Here, I can see it, is maybe the imperfections from the small data, because if we use small data in machine learning algorithms, sometimes they are not perfect. And many of us probably we have trained or fine-tuned large language model with few data, and we make them to generate text, and then the text is a bit incoherent. So we are in the necessity of, we need to get more data, to grab more data for this model to be actual perfect and coherent and work well, no? So in this case, maybe the live coding ethos of working in real time actually points us or push us to the idea of maybe we want to embrace these imperfections, we want few data, we want data that we can collect in real time, and maybe this is the type of data we want. Maybe we don't need to use big data, because probably using the data we are able to generate, probably that's enough for what we want to do. And I was actually thinking, for example, as artists, we would love to, we want to be special. We want our pieces, we want our artworks to reflect what we are. But I'm not sure if we as a human, we can generate a large data set in our lifespan. Probably not a human. If I collect all the texts I have written in emails, text messages, the pictures, the photos I'm in, or the pictures I have taken, probably those data sets are not even enough to train a large language model. So as an artist, even I have to give something away and to use data that is taken from other persons, which is what we are doing in large language models. But one different position for that could be like, do I want this? Do I want to use data that is probably not my data, that comes from other places? So that, of course, is, most of us is like, okay, but maybe I want just to generate a really perfect text, giving everyone the impression that this is actually alive, or this machine has actually some sort of intelligence. But in live coding, probably sometimes I just want to use the data I'm generating and work with that. So I think this is what Niklas was saying, like maybe what we want is a small data sets. We want to embrace those imperfections, and we want to use data sets that are also that they also have human scales, and they can also be analyzed, looked, cleaned, and all of that in real time. So this is what Niklas is saying. This idea of smallness can be extended to the model itself, with the observation of the models, the rules the model inferred from the data, can learn, can be analyzed, are semantically meaningful for us, no? For we people that we are playing there with the data and trying to act instantaneously, no? In this sort of real time. So real time, in that sense, extending this idea of small data to time, is probably not 20 milliseconds. It's probably something that can happen in a performance in the 9 minutes of the from scratch. But in this case, maybe it's also a perceptible response for the machine to the human. It has not. There is no need to be instantaneous. It just need to be perceptible. Something that is actually happening in the moment. So, I mean, the 20 milliseconds or the 3 milliseconds is this idea of instantaneous, no? This idea of what we perceive as changes in sound to be real time. And for example, for timbre transfer, if we want to convert my voice into someone else's voice, that is something also we have been doing. These 20 milliseconds, less than 20 milliseconds, I perceive those changes as a real time. But maybe that for something else, maybe in this context, no, going to live coding, it's something that real time is something that I can perform on stage as I'm performing. So there is also this question of the real time that I'm not want to get into it. And for example, I love this performance from Mariah Ballman, The Machine is Learning, because what she was doing was far from being real time in the sense of 20 milliseconds, but all the performance she's showing, she's collecting the data, she's training and retraining the algorithms until the machine learns. And it's a way to purely express all the machine learning process as a part of the performance. Watching someone training the algorithm, collecting the data, and then generating the output is a performance itself. So this is like to me, one of truly or a pure live coding performance in the sense of live coding and machine learning. And taking these tensions, of course, Markov chains, you know how Markov chains work, probably for sure. This they build this matrix, Markov matrix, and then in each entrance is the probability of one state to go to any other of the next states. And that could be, like, to me, those matrices are like the beginning of what could be like deep neural net matrices. But this idea of Markov chain versus neural nets also, to me, I start asking the question of which algorithms work more in machine learning, algorithms work better in the live coding context. So I wrote these other things. Now I came to talk about my book. Sorry about that. But to me, this paper was Symbolic is the New Life. And basically the statement was like, maybe symbolic algorithms are more suitable for live coding. And there are also people working with symbolic algorithms and combinations with sub-symbolic ones. Like symbolic algorithms is those type of algorithms, or are those type of algorithms that we can actually understand the output, like rule learnings. If we generate rules, we are able to understand the rules. Like decision trees, for example. Decision trees, they create something that are called if-then rules. Like if this parameter has this value, and this parameter has this value, and this parameter has this other value, then the output is this. These symbolic rules, like if, then, are understandable, are human readables, in contrast to these, the matrices of the the deep neural nets or the neural nets. So to me, in the context and also in an artistic context, for something that the artist can actually read and saying like, okay, these rules, if we are codifying the things I've been doing in a data set, in a model, and extracting some model, and if the model are a set of rules, maybe I'm more likely to understand what is happening. And maybe from that information, I can do something else rather than only looking at numbers in a matrix and trying to figure out what is happening. But of course, probably combinations of those for not being do not advocate for Puritanism, maybe that's also a possibility. And also, in live coding, this is yet another paper. We also want, like, for all the people that is doing live coding with machine learning, where are they actually touching the parameters? What are we doing? In which part of the machine learning processes we are developing the piece? Is it in the data collection? Is it in the training? Is the training happening online? Is the model selection happening online? Or is only the generation? What is happening? What of all these part of the machine learning process is happening in real time? So this other paper was about thinking on in which moments, no? Where are the moments, where are the spaces we can intervene these algorithms and actually try to have this dialogue with the algorithms? Where are the creative spaces in the learning algorithms? Or are they creative spaces? Which one are them? So, so this was also part of the idea, like symbolic is maybe the new life, but also there are moments, no? Every algorithm allows us for some moments of some spaces we can actually intervene in this learning process. And so sometimes, and this is a spoiler of a workshop that is going to be part of Hybrida's encounter. This is a spoiler. There are ways to, where are my, okay. There are ways to explore. For example, here I have a synthesizer of 10 parameters. And I can move the parameters and explore the different possibilities of the synthesizer. But in synthesizers, the space, the parameter space sometimes is really huge, and sometimes it's not linear, and sometimes it's really hard to know. Sometimes I remember talking with Ángel Faraldo, probably you know Ángel Faraldo from Fonos, and he was saying like, I love when I found a particular combination of knobs in the performance, and sometimes I know I'm not going to be able to come back to this moment. So he was saying like, and those moments are beautiful, no? But in computer science, we said like, let me say that moment for you, no? So you can just go here, select a point in the X, Y space or projection, and then just add the point. So we have this point over here. So in that sense, this is a neural net, and I was doing this, or this is what I'm going to do. I was saying like, okay, I would love to map my parameters into this space, and I'm going to put everything that is like a chorus on the top, like a choir, everything that is ghosty in the middle, and everything that is rocky on the bottom of this. So I said like, okay, so ghost or rocky. Maybe these are rocks. So I will at this point, more rocks, no, more rocks, nice. I will at this point, I'm going to collect 2 of them, 2 points for each. This is more like a chorus. So, no, maybe, yes, that's a chorus. there is also that problem of the categories, no? How many categories can we keep in mind, and if those categories are interesting enough for us? And let me look for some ghosts. No, there are ghosts here, but sometimes they are difficult to. Ghosts are difficult to find, not all the time. This is a ghost. Okay. I'm going to at this point. So I can save the data, then load the data, then train the algorithm for a while, and can save the model, load the model, and then I can change from not predicting, where I'm exploring the space, to predicting. So now if I go up, I will have like sort of chorus, but I have few points. I have like 2 in the top or 3, a ghost here, and rocks over here. So how big is the data set? In this case, it was like 2, 3, 4, 5, 6, maybe 7 points. So out of 7 points, I'm able to do something interesting and using a multi-layer perceptron. So for a live coding or for some artistic practices, I can think about like how big the data set has to be. What do I have? Is interesting enough? Can it happen in real time? Can it be included as a part of the performance? Are the people being aware? Is the audience somehow aware of what am I doing? Are these processes transparent to the public? This is the volume. Fortunately, we have a volume control. So not this one, I want this one. So these are examples. This is what I'm going to try to do during the Híbridas. I'm going to review some rhythmic processes, some more synthesizers like this one, more ambient one, and trying to see, letting the people to experiment how big the data set has to be for it to create, or for us to be able to create interesting rhythmic patterns or music with it. And this is an interesting question, because maybe we don't need big data set, or we don't need big complex algorithms, depending on what we want. Maybe small data, maybe symbolic learning are options that are there and are part also of the machine learning stuff or paradigm. So with Transformers Attack, I don't know what do I have over here, but there is this, yes, of course. This is Raffaele Andraggi and Felipe Noriega from the Netherlands live coding community. So they were actually, Felipe here is actually displaying. So in Transformers, in a sense, I've been thinking a lot. And live coding is safe because what it needs to be displayed is the grammar. And if the text generation or the code generation is completely automatic, then I'm missing the interaction with the human. So of course we know that text can be generated from large language models. And that also applies for the idea of someone playing the guitar. If someone is playing the guitar, it's like, hey, could you do that with also with automatic tools? Why are you playing the guitar? It's like, we don't want that in the live coding community. What is interesting is to see the human and the tensions and the frictions between the human and the machine. What is interesting in the live coding community is to be part of, to watch this conversation. What the human is doing, what is happening, where are the errors come from. I read the other day a paper that they were using a large language model for live coding, and they were like, and we work with the system until no errors can be committed. And I was like, then what is the point of being live coding if you cannot make mistakes, if you cannot make a typo, no? So for example, Felipe was displaying the conversation. Felipe was asking the ChatGPT to create some super collider code to be executed live. And he was saying like, no, this is crap. Make a good drone, no? So the conversation, and Felipe also was live fixing the errors, because sometimes the code was not even able to had errors or was not able to execute. But he was fixing, and the performance was about this tension between Felipe, this conversation with this agent, and the live fixing, the conversation between, you think these are a good drone, but this is not a good drone, make a good one, what is happening? But so far, in this particular case, in the live coding, because live coding is about grammars, because live coding is about real-time conversation with algorithm, this is so far the things I've been able to see with, in particular with large language models, with transformers, that otherwise most of the other artistic practices, they are a lot, they have the presence of a lot of works made by large language models. I think that's going to end soon somehow, because we already have seen a lot, so I don't think that has much of space, no, of free space for that. What's it? Oh, I've been talking a lot. Sorry for that. So this last slide, to me, it's like I would rather look at you and ask you, no, if like, am I human? We are humans. What do you think is our role, no, as creators, as persons, as artists, as designers, as all these sort of things that we do in this within this paradigm? No, I've been trying to answer those questions from a live coding perspective, because most of the time I'm a live coder, but I would also love to listen to you and to try to or hear, no, what you want to say. So maybe I finish here, and if you have any questions or you want to say something, this is the time. I pass the microphone. Ramon is already escaping, so Niklas has.
One thing that I always think when I hear the word conversation, and this is less maybe a question, but also like a general comment on that, but I feel like, especially if you talk about models and conversation, then there's always the two sides. You can have a conversation with a large language model, and you can ask it, hey, make a better code, or write the code, fix the error or something. But the next person who will ask the same prompt probably will get the same answer at first, because you cannot change the model with the conversation, and that's always like a fundamental difference. If I talk to a human, then I can influence the human, and the human can like do something different in their life if the conversation is inspiring. So in that sense, can I have a conversation with the model and change the model through the conversation? That's always a category for me that seems important when I think about small data and like real-time interaction with the model. Because again, like, can ask a large language model, and that model won't change. It won't be retrained. What's on the data that's on the server won't change at all. So that's yeah, just a comment on the idea of conversation, because I think that's kind of important in that context. I don't know if you have a comment on that.
So I feel that large language models deceive you, making you feel that they have different ways of conversing, no, or telling you in a different way. Like I've been doing like asking each time to give me some answers, and every time it gives me a different way to answer the question, no? So it makes me feel like, why? Like, why are you not like automatizing this this thing, no? So it makes you feel that it's actually kind of has autonomy in the way that can answer, no? But in reality, that's kind of a probabilistic, again, way of behaving, no? But for me, it's the deception that is very, or I don't know, I felt that it was something for me that it's not that it's retraining itself, it's just that in its training, it has that possibility of changing their answer if you ask many times the same question. That was all my comment.
We have 4 minutes to talk. It's well well, first what Niklas was saying, it's really beautiful. So the idea of having, I remember in the manifesto there is this idea of programs are instruments that can change themselves. So it's always nice, and that's the spirit of, that was the spirit of changing grammars. What would happen if we change the grammar as we speak? I start talking to you or speaking, and as I'm speaking, the grammar changes. So now I'm speaking because I know the grammar, but what if the grammar is changing? How is my way of speaking change with as the grammar is changing? So having the idea of programs that can change themselves, of having this idea of real-time feedback, which is sort of what now the industry is going, like I can fine-tune with my own small data set, and in that sense, it's like a small data set on top of a really big trillions of parameters. So we have learned how to personalize that, because without personalizations, there is a point in which we cannot get new or more interesting answers, no? And also connect what you are saying. It's hard to know how the technology works, even though we understand perfectly how it works. What we don't understand, because we know how in each neuron the inputs are added, we know the threshold functions, we know the layers, we know the architecture, we know backpropagation, we know everything. We do understand how this technology works. What we don't understand is the models that are produced with the technology. And what is actually imprinted in the model is what is difficult to know, even though we understand the model quite well, or the technology. And that applies to what you were doing, like what you were saying, no? Like every time, well, maybe you can use a seed, but every time you ask a model, maybe you can have something different. And maybe using a seed is like, I don't know how this works because I don't know all the architectures, but then it could be like, let's use this as a sort of input for text generation, so most of the time we more or less have the same. I don't know if that's your experience, or if you have worked with seeds for that. That's nice. Which model was that?
It's a Mixtral. It's called Mixtral. It's like a ChatGPT, but in with another company. But it gives you, what I was trying to do is to extract text from a very complex text, to extract information from it, and it gives you weird things every time. Like it's correct. It's very impressive how correct and precise it is sometimes, but sometimes it just gives you, like the way that it's formatted even though you tell her like, this is the way that I want it to be formatted, and it still does weird things. um, yeah, it's interesting for me. And also, I was thinking a little bit about the small data set. What does that mean to fine-tune a model? And because what we're like working with Aishan right now, she's a resident for Hybridas, and we are trying to work in small data sets that were fine-tuned in a large language model, no? And yes, what we're seeing is that small data sets in a large language model means that it's gonna not work. You know, so what is a small data set in a large language model? Well, like even if it's trained already with a lot of data, if you want to make it do something very particular, you need another layer of a lot of data. And you think that small data means maybe 100 points. 100 points is not enough to make it actually work. So you are in a conundrum, no? Like, what are we looking for here? I don't know. I feel that that's something that we're discovering right now.
Okay, no, then go to them, or like. Okay, no, I thought there were questions in the channel. So I haven't really experimented that much with large language models, but question to those who did. If you tell the large language model, I'm sorry, your answer is completely wrong, what does it do? Like, okay, and the next time you ask, it gives you the same wrong answer, or like, so I guess that's okay. So that's kind of like, yeah. I don't know. That's a litmus test in some sense.
Yeah, sorry. You can play with the temperature of the model if you want it to be more deterministic, for example. If you go into ChatGPT Playground in OpenAI, then you have a range between 0 and 2 for the large language model to be either more deterministic or either more creative. So the more creative is the model, the less it's going to follow your instructions. So I don't know if you can do that with Mistral, but since it's open source, I guess that you can completely modify it. Hmm. Y- Yeah, I'm not talking about prompting. Of course, you can access. Mistral doesn't have an API, but I'm sure that there's a way you can. Yeah, of course, you can just download the model and play with the model. So to change the parameters, actually, so prompting, yeah, of course works. But if you want to actually change something, then go to the parameters of the model and change it yourself. Like, okay, yeah, okay. I haven't tried it but I don't know if it works like GPT, but I mean, I'm sure that you can do it. Like, maybe it's more complicated than in GPT, but yeah. So if you want it to be more deterministic, oh yeah, yeah. It does. It has to.
Maybe for the time, I should wrap this up. I mean, it's really nice what you were discussing, because it's like in Markov chain when you were playing, like when we were kids, no, playing with the degree, no. If you look only for one step or one state behind, or for two or for three, and for really long steps, we were actually getting something really similar to the data set, in that sense being less creative. And for really small steps, we were actually getting something more chaotic. So that's also nice. And another thing, I don't have but I can put it in the channel and show it in while we are wrapping up. recently I also had a discussion about what actually AI can do for music generation. And I'm not talking about the music industry. Of course, it's really nice to have a prompt and create a song for, give me a sad song with violins and a quartet and anything, and we give it. But that's something that is, in my point of view, is not creative or not new, but is more industry oriented. So I was actually trying to answer the question of what actually can do, can artificial intelligence do that is new in the sense of music generation. And I found few examples, most of them in sound synthesis. For example, this possibility of combining many voices to create a new voice that we have been working, or timbre transfer, being able to play with someone else's voice. There are few things, but most of the development is industry oriented rather than creatively oriented, or in that sense. And that's something really interesting to think about, like in our own fields, in design, in artistic, in our artistic practice, in live coding, what is actually new, not faster. What is actually new that we can tell for sure that, oh, this is something that we couldn't get anyway, or probably less likely following other path. And of course, when the Deep Dream video on Deep Dream appear, of course the aesthetic is something that is new. That is something that probably following other path we can do it, but some of the aesthetic is actually new and interesting. In music making, there are sound synthesis on particular synthesis processes. We can create things that otherwise it would be difficult. But in terms of form or lyrics or harmony, it's hard to find examples of cases in which we can actually say like, this is something that AI offers that is truly creative, or truly opens new possibilities to work with this. So that's also like a really interesting exercise for all of you in our own fields. Like, is there something new, or what is something new? Because then maybe we can actually visualize the creative possibilities of technology, of this technology, rather than more industrial or industry-related possibilities that sometimes are presented as creative possibilities, no? Instead of more like industry optimization or automation. That is actually and don't take me wrong, I really like so my PhD was actually about machine learning. So I've been actually thinking on this and trying to figure out how it works, how it is, and what it can offer apart from letting us play using Super Collider that otherwise it's just hard to use. Okay, thank you. I don't know if anyone wants to add anything else. If not, thank you very much for being here.